T1 is uncut chip thickness and T2 is chip thickness. Okay. So this cutting ratio is basically divided into two types. First is chip thickness ratio. This chip thickness ratio is denoted by small r, and it is the ratio of the uncut chip thickness to the chip thickness. Okay. Now you have to tell me that this ratio of uncut chip thickness, I have given you three options. Basically, it is the ratio of this to the ratio of this. Okay. So you have to tell me this is a shear plane. So you have to tell me this ratio T1 by T2 is equals to 1, is less than 1, or is greater than 1. Or if I want to keep it this way, whether the chip thickness is equal to the uncut chip thickness, or it is more than the uncut chip thickness, or it is equal to the uncut chip thickness. Means when you are doing the machining, basically this will get converted into chip after some time. This will get converted into chip in some time. So you have to tell me whether this thickness and this thickness both are equal or not. Tell me. Someone have given the answer that it is less than. Someone have given the answer that it is less than. So that answer is actually correct. Okay. Always the thickness of the chip is more than the uncut chip thickness. The thickness of this chip, this is always more. T2 is always greater than T1. So this ratio is always less than 1. Okay. This ratio is always less than 1. Similarly, one more ratio you have. That ratio is known as and that ratio is known as chip reduction ratio. Chip reduction ratio. The chip reduction ratio is denoted by R dash, which is T2 by T1, and T2 by T1, since T2 is always greater than T1, so this T2 by T1 ratio R dash is always more than 1. This is less than 1 and this is more than 1. Okay. No one asked me a question, sir, when the same material the tool is cutting, which is the uncut chip thickness, the same material, then why the thickness of the chip is more than that of the T1? Do you have this question in your mind? Do you want me to explain or you got it? You got it or you want me to explain? Explain. Good. See, yesterday itself I told you that how continuous chips are formed. If I want to show formation of continuous chips here, then how can I show that? Continuous chips are formed by the shearing action along the shear plane. So you will get a geometry something like this. Right? Yesterday itself we have seen that's like this continuous chips will be formed. Now we have got something like this. The magnified view I am drawing here. Okay. See. So chips will be formed something like this. Okay. So basically, uncut chip is something like this. It is completely straight, but this chip is zigzag. Okay. So if you take this thickness, which is T1, and if you take this thickness, which is T2, so this T2 will be always greater than T1. The chip thickness is always greater than the uncut chip thickness. Why? Because of those irregularities on the surface. Due to the plastic deformation, due to the shearing action, if you take the thickness of the chip and when you compare the thickness with the actual material from which the chip is been produced, you will notice that the T2 will be always greater than T1. Okay? Is it clear or not? Is it okay now? Say yes or no. It's clear now. Okay, good, good, good. Sai Madhav got it. Okay. Now, next, we will discuss some important definitions. Okay, we will discuss some important definitions. The first definition is shear angle. Definition of shear angle. Can anyone tell me what is shear angle? Can anyone tell me what is shear angle? Anyone have any idea? Have you studied shear angle? This is the tool. Okay. This is the alpha naught angle, which is the this is the reference line, this reference plane. Okay. And I already told you that the plane across which the shearing takes place is known as the shear plane. So basically, this is my shear plane because across this plane only the shearing is happening. So this is known as shear plane. Okay. Now all of you pay attention here. I'm explaining about the shear angle. So before explaining or before understanding about the shear angle, you should first understand about the cutting velocity vector. So what is this cutting velocity vector? This is the workpiece. This is the atmospheric surface. And this is the machine surface. All of you pay attention. If you don't get it, you will be in trouble. This is my tool. Okay. Okay. Now the cutting velocity vector is something like this. This is the direction of cutting velocity vector, which I call as VC. Okay, or I would say V only. So this V is nothing but cutting velocity vector. Okay, because in this direction only cutting is taking place. So the definition of shear angle is the angle made between the shear plane and cutting velocity vector is known as shear angle. Angle made by, or the angle made between the shear plane and the cutting velocity vector. So since this arrow is my cutting velocity vector here, so in this particular diagram, this is my uncut chip and this is my chip. Okay, this is T2, this is T1. Okay, so can I say that this is the direction of my cutting velocity vector? Is it V? Say yes or no. Say yes or no. Say something. Actually, you are looking from the orthogonal plane. Na? Whatever you are seeing here, it is the orthogonal sectional view. So this is the orthogonal plane and you are looking at from here. You are looking at from here. That's why you cannot see this machine surface. You can only see this part. Okay. So in this you are seeing the tool, the uncut part and the chip part. Since the cutting velocity vector is pointing in the upward direction, so can I say that this is also the cutting velocity vector in this diagram? Reply fast so that I can understand you are getting or not. Right? Within the cutting velocity vector. So now, as per the definition, the angle made between the shear plane and the cutting velocity vector is known as the shear angle. So can I say that this angle is my phi, and phi is nothing but shear angle? Phi is nothing but the shear angle. Can I say like that? Clear? So that is the shear angle. The next is shear velocity. Shear velocity. We represent it by Vs. So the shear velocity definition is the velocity of chip with respect to workpiece is known as shear velocity. Okay. The velocity of chip with respect to workpiece is known as shear velocity. And so basically, what is shear velocity? Shear velocity is this one. This is Vs. It is shear velocity. Okay. Now, the third one is chip velocity. That is Vc. The velocity of chip with respect to tool is VC, which is chip velocity. So the velocity of chip with respect to tool means this velocity is my chip velocity. This is Vs and this is Vc. Is it clear up to here, everyone? I have basically given names to four terms here. One is shear angle, another one is cutting velocity, another one is shear velocity and chip velocity. So the shear angle is the angle made between the cutting velocity and the shear plane. So this is my shear angle, okay, as per the definition. Now the next one is shear velocity. First we have discussed about the shear angle, and then we are discussing about the shear velocity. The shear velocity is the relative velocity between the chip and the workpiece. The relative velocity between the chip and the workpiece. That is the shear velocity. So this is I'm calling as shear velocity, this direction in which the shearing is taking place. With respect to workpiece, how the chips are forming or how fast the chips are forming, that is the shear velocity. And then I said about the chip velocity. So it is the velocity of chip with respect to tool. So with respect to tool, how fast the chip is moving, that is the chip velocity. Okay, that is the chip velocity. So the velocity of chip with respect to workpiece is shear velocity, and the velocity of chip with respect to tool is the chip velocity. Okay, in both the cases we are taking the chip velocity only, but in one case we are taking with respect to workpiece, which is getting the shear velocity, and another case we are taking the velocity of chip with respect to tool, which is coming out to be as chip velocity. Okay, is it clear up to here? Is it clear up to here? Say yes or no. Say yes or no. Are you able to listen to me? What about others? Others 37 students, they never reply. Yes, Sheikh, you got. Asha Kiran, are you there in the class? Tejaswini, what about other students? If you won't reply, one day I will cross verify each and everyone, and then I will start marking absent. Okay. Okay, Tejasvi, you are very silent. You are not asking doubts today. So the next topic is we will establish a relationship between. Okay, Asha Kiran. We have established a relationship between cutting velocity chip velocity and cutting velocity, chip velocity, and shear velocity. Okay. So cutting velocity is V, chip velocity is VC, shear velocity is VS. And this particular topic is very, very important. Okay. 4 stars I'm giving. Because in the exam straight away, this is asked for 14 marks or 7 marks. Straight away in the end exam. They will ask you to derive the expressions for chip velocity and shear velocity, or they might ask you to draw the velocity triangle or something like that. But basically, this question will be asked, this derivation will be asked. Sometimes we also call it as velocity triangle concept. Velocity triangle. How many of you are from Vizag? From Vizag city, how many of you are there? Meanwhile, I'm drawing the diagram. Tell me how many of you are from Vizag? Hemant. Only Hemant? You are also from Vizag. It's raining na, today. At my location, it's raining heavily. So anytime I might have a power cut, so the class might stop in between. Okay, okay. It's very heavily raining today. See, every time I draw the diagram, that is not because I want to waste time network problem also. Okay, here I have broadband, so I don't have any network problem, but anytime I might have a power cut. So I'm drawing tool every time. Tool means this diagram every time doesn't mean that I want to waste class time. You have to learn how to draw these diagrams, okay? Or else you will not be able to draw these diagrams in the exam. Okay. What is this? This is the reference line. Okay. This is the angle alpha naught. Can you see this line? This line is it visible or shall I change the color? This is shear plane. Okay. It is shear plane, which we represent by phi. This phi is shear plane angle. Okay. This is T1. Just a minute, I will close the window. Okay. This is my uncut chip thickness. This is T1. And this is the chip thickness, which is T2. So this is chip thickness, which is T2. And this one is uncut chip thickness, which is T1. Okay. That is the uncut chip thickness, which is T1. Now, if I reproduce this line backwards, okay, and I reproduce this line in this direction, okay, and if I join this, if I join this like this, okay, now I am calling it as This one I'm calling as VC. You see, it is the chip flow velocity. This I'm calling as VS, and this was my cutting direction of cutting velocity vector. Okay, is it clear up to this point? Everyone, say yes or no. Is it clear up to this point? Clear now? No doubts. It's clear. Okay, good, good, very good. Okay, so you have to tell me that if this angle is alpha, then what is this angle? Tell me. If this angle is alpha, this angle is alpha. If this angle is alpha, then what is this angle? Observe and tell me. Same alpha. How it is alpha, Madhav? How it is alpha? Tell me. How it is alpha? If this is alpha, this angle is also alpha naught because of vertically opposite angle. Okay. Now, this is 90 degrees. This is 90 degrees. So this is what? 90 minus alpha naught. This angle. Let us give it name. Let us give this A, that is B, that is C, that is D. Okay. So this is 90 minus alpha naught. Okay. Clear? Now, this line and this line both are parallel to each other or not? This AC line and this red line both are parallel to each other, and this line is same line. So if this angle is alpha, this angle is phi, this angle should be also phi. Did you got this? What I said? This line and this line, they both are parallel to one another, and consider this as the transversal. Okay, so this angle and this angle both should be same. So that's why this angle is also qualifies to be phi. Now, this is 90 degrees. So this will be 90 minus phi, right? 90 minus phi. So I hope that up to this point, everything is clear to everyone. Okay. Now, applying in triangle A, B, C, apply sine rule. Okay. In triangle ABC, apply sine rule. So what will be there? Sine rule, you know, na? So this side is V. So V divided by sine of how much? This angle, this complete angle. So how much it will be? 90 minus phi plus alpha naught. Sine 90 minus phi plus alpha naught equals to, now this VC by this angle. So it will be VC divided by sine phi, then VS divided by, this is VS divided by this one. So how much it will be? Sine 90 minus alpha naught. Just look at this expression. Is it okay? Clear to everyone? Is it okay? Clear to everyone? Any doubts? Anything? Nothing? Na? Okay. So I'm moving to the next slide and I'm writing the same expression what I have written. That is V divided by sine 90 minus phi plus alpha naught equals to Vs upon sine 90 minus alpha naught equals to Vc divided by sine phi. Okay. Now can I rearrange it taking the minus common? Can I write it like sine 90 minus phi minus alpha naught? Okay. Equals to Vs upon sine 90 minus alpha naught equals to Vc upon sine phi. Okay. We all know that sine 90 minus theta equals to cos theta. This is basic trigonometry, right? So I am changing this sine term into cos term. So I'm writing here V cos phi minus alpha naught equals to Vs upon cos alpha naught equals to Vc by sine phi. Okay. I'm writing it like this. I'm rubbing it. You understand that I have applied 90 minus theta there. So now what am I doing is I am trying to establish relationship between the Vc, Vs and V. So basically, if I equate these two terms, if I equate this term and this term, and if I equate this term and this term, I will get two expressions. First expression was for the chip velocity Vc. So Vc by sine phi equals to V by cos phi minus alpha naught. So Vc will be V into sine phi divided by cos phi minus alpha naught. Okay. And the second one is Vs equal to V into cos alpha naught divided by cos phi minus alpha naught. So these two expressions are very, very important expressions, and we will be solving some problems based upon these two expressions. So you just look at the derivation once and tell me that is it clear to everyone. Just look and tell me that is it clear to everyone or not. Just look at the diagram and tell me. Is it clear to everyone? Meanwhile, I will be looking to give you some questions. See if any questions are available on this. Is it clear, Asha Kiran? No doubts, no? So after you have understood this, I request you to write down the final expression on a piece of paper. You write down these final expressions, Vc and Vs. Vc means chip velocity and Vs means shear velocity. Okay. Have you noted it down? These two, or take this screenshot. To take this screenshot, no need of noting it down. Take this screenshot. Take the screenshot and we will solve one simple problem. Have you taken the screenshot? I'm moving on to the next page and write the question. The rake angle of a cutting tool is 15 degrees. Shear angle is 45 degrees. And the cutting velocity is 35 meters per minute. What is the velocity of chip along the tool face? Solve and tell me answer. You know the formula. Substitute the values and tell me the answer. Just wait, I will check. 28.57 meters per minute. Right? Correct. How many of you have? Yes, 28.57 is the correct answer. See how to solve it. It's very easy. Alpha naught is given as 15. Okay. Phi is given as 45. And cutting velocity V is given as 35 meter per minute. Okay. Right. Correct answer. So VC equals to V by sine phi divided by cos phi minus alpha naught. So V is how much? 35 multiplied by sine 45 divided by cos 45 minus 15. So when you solve it, the final answer is how much? Just comment once. 28.57 meters per minute. Those who have solved it, good. Those who didn't solve it, note it down. Those who have solved it, good. Those who didn't solve it, note it down. Okay, so one hour is over. If anyone want break, or you want me to continue? If you want break, tell me, or else we will continue. No response. So the next topic is, we'll continue then. This is also very, very important topic from semester exam point of view. Relation between T1 and T2. Relation between T1 and T2. So what is T1? What is T2? T1 is uncut chip thickness. T2 is chip thickness. Okay. Now let's begin the diagram. This is the workpiece. This is the shear plane. This is the uncut chip. This is the tool. This is the reference line. This angle is orthogonal rake angle alpha naught. What is this angle? Shear angle phi. And this is my chip which is flowing out. This is actually T1 and this is T2. And I want to have a relationship between T1 and T2. Okay, this is what we wanted to have here. Okay, I'm doing a small construction here. The construction is dropping two perpendiculars from this point. I'm dropping one perpendicular here and I'm dropping another perpendicular here. Okay, I'm dropping two perpendiculars. This is the construction. Okay, so I'm naming it as A and this as B and this as C. Okay, and here it is O. So I am drawing a magnitude view of this particular diagram here. Here I am drawing. This is the rake face. I change the color. This is the rake face. This is the reference. This is the reference line. Okay. Now there's a this OA line. Okay. This is the OA line, and now this is the AB line. Just a minute, it got hanged. This is the AB line. This is the OB line. And this is the BC line. Okay. This is A. This is B. This is O. This is C. This is one perpendicular. This is another perpendicular. This angle is alpha naught. This angle is psi. Right? Okay. And what is this? This is my T1. Okay. And what is this? This is my T2. This is T2. Is it clear up to here? Any doubts, anyone? Anyone having any doubt? No doubts? Nagendra Kumar responded first time. Okay, okay, okay. Now you have to tell me the angles. I will ask you and you have to tell me which angle is what. See here. What is this angle? If this is phi, you can see clearly that it is 90 degrees. OA line and the reference line is 90 degrees. This is reference plane. Now what is this angle? Tell me. Tell me that is that angle. Tell me what should be this angle? Can I write it 90 minus 5? Do you have any problem if I write it like 90 minus 5? 90 minus 5 only. You are getting this kind of special symbols from where you are getting, Santoshi? I never found in my keyboard these special symbols, phi, theta, alpha, everything you are writing. So after this is 90 minus 5. Now what is this angle? Now what is this angle? This is 90 degrees. This whole angle is 90 minus 5 plus alpha naught. Okay. So this angle will be 90 minus 5 plus alpha naught. 90 minus you have to do with this. So 90 minus 90 plus 5 minus alpha naught. Okay. So this 90 and this 90 will get cancelled and you will get 5 minus alpha naught. So this angle will be 5 minus alpha naught. Clear? Is it okay? Is it okay up to here? If you got this, 50% of work is already completed. Have you got it? Now, any doubts here? No, no. If any doubt, you just stop me. I will repeat it. In triangle AOB, what is sine phi? Tell me. In triangle AOB, AOB means this triangle. In this triangle, tell me what is sine phi. Sine phi చెప్పండి. T1 upon OB. T1 upon OB. Yes or no? T1 upon OB. 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 This is phi. This is perpendicular. This is hypotenuse. Sine theta is perpendicular upon hypotenuse. All these things you must be knowing, I guess. Right? In triangle DOC, in triangle AOB, and in triangle BOC. What is cos phi minus alpha naught? So in this triangle, in this triangle, in this triangle, I am asking you what is cos phi minus alpha naught. Tell me. What is cos phi minus alpha naught? Tell me. What is cos phi minus alpha naught in triangle BOC? BC upon OB, BC upon OB. Very good. BC upon OB. BC upon OB. So cos phi minus alpha naught is BC upon OB. BC is T2 upon OB. This is my equation number 2. This is my equation number 1. I am moving on to the next slide. Anyone having any problem up to this point? No, no. I am moving to the next section. And I will be writing the equation number 1 and equation number 2. So my equation number 1 was sine phi equals to T1 upon OB cos phi minus alpha naught equals to T2 upon OB. Okay. Now I want relation between T1 and T2. That's why I'm doing dividing equation number 1 and equation number 2. Okay. So when I divide it, T1 upon OB into OB upon T2 equals to sine phi divided by cos phi minus alpha naught. Okay. So this OB and this OB will get cancelled. So T1 upon T2 equals to sine phi upon cos phi minus alpha naught. Okay. Okay. In the starting of today's class, I told you one thing which is known as the cutting ratio, in which I told you that if T1 upon T2 is there, I can call it as R, right? So here also I got T1 upon T2, so I can call it as R only, which is the chip thickness ratio. Okay. So here T1 upon T2 equals to R equals to sine phi upon cos phi minus alpha naught. Okay. Now you have taken screenshot, na? You have taken some screenshot. In that screenshot, you tell me what is the relation of VC by V. మీరు ఒక ఫార్ములా రాశారు కదా, for VC you just see that formula and you see that is also equals to sine phi by cos phi minus alpha naught. Say yes or no. That is also sine phi. Yes, good. So that screenshot formula, that is equation number 4 and equation number 3. So since the RHS is equal, I can say that T1 upon T2 equals to R equals to VC upon V. Okay, this is very, very important relation. This is very, very important relation. Okay. Next, we will continue. We'll continue from here. We'll continue from here in the next slide. R equals to, that is T1 by T2 equals to R equals to sine phi upon cos phi minus alpha naught. Okay. Now all of us know one very frequently used formula, that is cos A minus B, that is cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. So here if I apply that cos A cos B and sin A sin B, then it will be R equals to sin phi divided by cos phi cos alpha naught plus sin phi sin alpha naught. Okay. Okay. Now what am I doing is dividing numerator and denominator by sin phi. So if I divide numerator and denominator by sin phi, this will be sin phi upon sin phi whole divided by cos phi cos alpha naught divided by sin phi plus sin phi cos alpha naught divided by sin phi. Okay. So R equals to this sin phi and this sin phi will get cancelled and get here 1 divided by this sin phi and cos phi will be becoming cos alpha naught upon tan phi. Okay. Plus this sin phi and this sin phi will get cancelled. I will get cos alpha naught. I am taking this entire term to the left hand side. So R cos alpha naught upon tan phi. Okay. R cos alpha naught upon. Just a minute, we have made small mistake. Here it should be sin alpha naught. I have written cos alpha naught. Small mistake. Sorry. This should be cos alpha naught. Sorry, sin alpha naught. Sin. This should be also sin alpha naught. Clear now? What mistake we have committed? Are you have you got it? Just in the formula, I have substituted the wrong trigonometric identity. Trigonometric ratio I have substituted wrong. Okay. So this will be plus R sin alpha naught equals to 1. Okay. So this is R cos alpha naught by tan phi equals to 1 minus R sin alpha naught. Okay. So what is the term? R cos alpha naught tan phi R cos alpha naught divided by tan phi equals to 1 minus r sine alpha naught. Okay. R cos alpha naught equals to 1 minus r sine alpha naught multiplied by tan phi, or I can say tan phi equals to r cos alpha naught divided by 1 minus r sine alpha naught. Okay, this is one of the most important relation to find out the shear angle, or I can write it like phi equals to tan inverse r cos alpha naught divided by 1 minus r sine alpha naught. This is very important relation for finding shear angle. For finding shear angle. Is it clear, everyone? You want to see the derivation each and every step once again? You want to see the derivation each and every step once again? Yes. Okay. See. See each and every step once again. I will keep the slide for 1 minute. Now I'm moving on to the next slide. Okay. Now you tell me, if rake angle is 0, then what will be the value of my tan phi? If rake angle is 0, what is the value of tan phi? R. Very good, very good, very good. Good. So what we will do is, we will solve few problems on this. Okay, and whatever problems I am giving you were previous year gate questions. Okay, they were not any textbook questions, they were previous year gate questions only. So if you are able to solve those questions, then I consider that you can solve any question of that kind in the exam also. I am giving you 1 to 2 questions. We will solve few problems. Okay. Just a minute. Shall I write the question or shall I dictate the question? Tell me. Shall I write the question or shall I dictate the question? Write. During orthogonal cutting of mild steel with a 10-degree rake angle rectangle tool, the chip thickness ratio was obtained as 0.4. The shear angle in degrees evaluated from this data is. Solve it and tell me. Yes, it's correct. So most of you are not giving answers. Tejasvi and other students are also not giving answers. So I was speaking something, but microphone was off, so you couldn't be able to hear. What I was saying is, from the first unit, one numerical problem will be asked. 100% one numerical problem will be asked. And if you won't be able to solve this numerical problem, and if you attempt to write the theory bits, correct, Asha Kiran? If you attempt to write the theory bits, then you will not get complete marks. Full marks you won't be getting. In 14 marks question, if you attempt a theory question, you will end up getting 10 marks or 12 marks, maximum 12 marks. If it is completely correct, then you will maximum get 12 marks only. You won't get complete 14 out of 14, because you know in theory we never give complete marks. But if you attempt problems, then problem if the answer matches, then we have to give you 14 out of 14. So that's why concentrate, try to solve these derivations and these problems, because they will get you more marks. Instead of this, if you try to write that geometry of single point cutting tool, if you get that question in the choice and if you try to attempt that question, then you will get the marks, but you will get less marks. Okay, so let's solve this question. Orthogonal turning, rake angle is given, chip thickness ratio is given, that is small r is given as 0.4. The shear angle is asked. So phi equals to tan inverse r cos alpha naught by 1 minus r sin alpha naught. So phi equals to tan inverse r is 0.4 cos alpha naught by 1 minus 0.4 sin alpha naught. Then if you solve it, you will get how much? Most of you have given the answers now. Once again, someone please tell me the answer. Sorry, I have to keep the alpha naught also. 0.4 cos 10 by 1 minus 0.4 sin 10. So if you solve it, you will get 22.94. Okay, 22.94 degrees. Is it clear to everyone? Anyone having any doubt in problems? Anyone having any doubts in the problems? Write down one more question, and this will be the last question of today's class. If you solve it, then I will be very happy, because you have got the concept it means. In an orthogonal cutting, the cutting ratio is found to be 0.75. The cutting speed is 60 meters per minute. Okay, the cutting speed is 60 meters per minute, and depth of cut is 2.4 mm. Calculate chip velocity and chip thickness ratio. Chip velocity and chip thickness, not ratio. Calculate the chip velocity and chip thickness. Solve it and tell me the answer. Completed? I'm not getting any answers. Yes, correct answer. VC equals to 45 is the correct answer. Good, very good. So let us solve this. Here, depth of cut is given. Actually, depth of cut we should never take as uncut chip thickness. But if nothing is given in the question, no other data is given, then you can take depth of cut as chip thickness, uncut chip thickness. So here, depth of cut is given 2.4 mm. Cutting ratio is given, it is 0.75. Cutting ratio, if it is less than 1, it means that it is chip thickness ratio only. So R is equals to T1 upon T2 equals to 0.75. So I wanted to calculate chip thickness. So 2.4 into, just a minute, T1 is given. So depth of cut is T1. So 2.4 upon T2 equals to 0.75. So 2.4 equals to 0.75 into T2. T2 equals to 2.4 upon 0.75. What is, how much you are getting this? Tell me. How much you are getting? 3.2. So 3.2 mm is your chip thickness. Next is you want to calculate the chip velocity. So VC1V equals to T1 upon T2 equals to R, right? So VC upon V equals to R. R is how much? 0. R is how much? 0.75 equals to VC upon V. V is how much? 60. So VC will be 60 into 0.75. How much you are getting? VC equals to, how much is 60 into 0.75? Tell me. 45 meters per minute. This is the chip velocity. Okay, so this is how you are going to solve the questions. And thank you very much for this session. We will end here. I hope you got it correctly. I hope. Okay, I have taken the attendance and now you can leave. Thank you. Thank you very much.